like
dynamics?
Yeah, dynamics in my head, but like rigid, meaning like they're like destruction and things like that.
No,
Okay.
nothing like that.
So in Houdini, they're called RBDs, rigid body dynamics. And we're going to start out by using the shelf tools, and then we're going to make some demos. So first of all, the way I like to work in Houdini, for those of you that are new, do you know how to navigate? Like just tumble, pan, and roll. So it's left mouse. You hold down the space bar. First, you have to hold down the space bar to do everything.
I didn't know you could do that with space.
Huh?
I just always did it with all.
Oh, yeah.
Is space bar easier?
It's probably the same exact thing. It's true. I think Alt does work. It's in the settings as well. You can change all that. But yeah, space left to tumble, space middle to zoom, and space right click to pan. So space left click, tumble, space middle, zoom, space right, pan. I also, and also Chase, can you remind me what the zoom thing was again? Those shortcuts? It was,
I'll pull it up on Google.
okay. At the upper right, you see there that we have a 3-window pane layout, and I want you to click off those little X's that you see next to parameter, take list, and performance window monitor. Just click those X's off. So we just have 2 panes, and in order to get our parameters up, I'm going to press P. But we'll get there in a second. There's nothing here yet, so you're not going to see it yet. But once we need our parameters, we're going to press the shortcut P. If you don't have a notebook to take notes, does everyone have a notebook to take little notes? Yeah? Okay. So just remember, P is for parameters. That's the shortcut. Okay. First thing we're going to do is use the shelf tool. The shelf tool's at the very top. That's what we're calling the shelf. And I'm going to hold down Command. On Windows it's Control, but on a Mac it's Command. Hold down Command and press this sphere. The sphere button right there. Okay. Okay, so I've got this sphere right here. And what I'm going to do is I'm going to take this sphere and I'm just going to peek. I'm going to peek behind you guys to make sure everyone's finished. Kamal, any chance you could get on one of these computers, really? That'd be awesome. Then I have my whole front row.
Command Option plus.
Okay, let me write this down.
Alright.
Command
Option.
Option
And then equals. Plus equals.
plus equals to go in and out, right?
Yeah.
Okay.
To go in, and then I'm assuming that's to go out.
Oh yeah, plus minus.
But before we do that, we just need to go and enable it in accessibility.
Oh right.
But I think it might already be enabled from last
Probably.
time. Yep,
Yep.
already got it. So we're good.
And you said in Windows it's Control.
Yep.
Yeah, but
Yeah.
but that's just a Mac Windows thing that's a global thing. It's not a Houdini thing. It's like whatever. Whenever I say Command in Windows, it's going to be Control.
Yep.
Also, this light is that. Can I put that on?
Sure. Yeah.
Yeah.
There we go.
Wake us up a little bit.
We started the page, right?
Let's just get Kamal up and running. Okay. So for you guys, okay, so you, go right there. Yeah. Okay, so now remember I said P was the shortcut for parameters? I want you to click the shortcut P right now. So hit P on your keyboard. Just one little tap of P. So P brings up your parameters. So we have, right now, we've got our network view up. This is where we put down our networks. And we lay down our nodes, but every node has its own set of parameters. And every time we click on a node, the parameters are going to switch to that node. As I go along, I'll introduce like some concepts like flags. I know it'll be review for the ones that you guys were there last week, but okay. So everyone up to speed? Yep. Okay. So we've got our sphere. We're going to drop our sphere onto the ground and have it react to it, like bounce a little bit. We need a collision floor for that. And for that, I want you guys to click on the collisions tab up here. The collisions, and that's the ground plane. So then we're going to hit Command, click on the ground plane. Command, click ground plane. Thanks. Need a different,
Marker.
Yeah. Yeah, so more useful tips here. You and I, and we haven't really dived in yet, but as soon as we do. Okay. So what do we have here? I'm going to zoom out. I want you to select your sphere, so I'm just going to, draw a little box around that sphere. And I'm going to take the handle, and I'm going to raise that handle up like that. So it's kind of floating in space. Thank you. Yeah.
You're going to use that up and down, right? Or do I?
It's the other way.
Oh.
You and I are swapped.
Okay.
Yeah. Because U is for up. Think about it like that.
Thank you.
Okay, so sphere. Next thing, I want you to look at the rigid body tab. The rigid body tab on your shelf. And that rubber ducky is called the RBD hero object. With your sphere selected, I want you to click on that rubber ducky RBD hero object. Okay, and now let's press play, and our ball should hit the ground. Sphere's hitting the ground. Courtney and Connor, 2 C's. Marcel and Kamal. Okay, so everyone here's got that. Okay, so now we're going to use these shortcuts right here, the I and the U. So to dive down, and maybe an easier way to remember this is instead of down, do in. And that way you can remember the I here and the U here, right? dive in, dive out. I, view. Okay, so you can, let's go into this AutoDOP network right here. And you can either double click inside, or you can just use this shortcut and go and dive in by pressing I to go in. I to go in.
How do you put up the parameter box?
P.
Oh, hello.
Yeah, you can also drag out the window so you can see your notes and have parameters.
So another shortcut. L. Layout. Layout. So click, you can select all your nodes. Select all your nodes, press L to lay it all out. And let's take a look at what's going on here. We've got this RBD, this is our source. This is going to be, this is our sphere. If you press P, let's take a look. This path refers to the sphere. If you look at the physical tab right here, check out these, bounce and friction. These are the things that if you change them, you're going to see a difference. So let's take our bounce and make it 1 instead of 0.5. So a little more bounce. Okay, now take your bounce to 2. There we go. Also, you can, this is not playing at real time, it's playing at just, kind of how fast your computer is. So click on this little icon right there. It looks like a watch or a clock right next to the key, and that will play your sim at real time. Yes?
Can you close out of it saying that second operation failed, object already simulated? Object already simulated. And the step we did before you got to this.
Okay.
Grab it here.
Let's see, you might, what's that?
Settings.
Oh, that's hard to see, isn't it?
Yeah, I think I'll easier.
So, go inside there. Just double click inside. You already have everything.
Okay.
Yeah, so it's probably telling you that, like, you already have everything. Yes.
Mine's not like coded up with the ability to like change the fonts and stuff. Or I
Change
don't know.
fonts. Go inside of the green node,
Anyone else have any issues?
Inside. Yeah, that's where it is.
Good. You're good?
Good.
Huh?
Physical.
You good?
And then your bounce is right there.
Okay. Are we
So everybody,
Bounce.
let me review for 1 second here. I'm gonna press U. I'm gonna press U to go back up. I am not on this top level. I'm not here. I'm actually inside of this green AutoDOP node. Press I to go in. Click on the rubber ducky node, the physical tab. That's where you're going to find your bounce. Does everyone have their bounce? Does everyone find that? Yeah?
Did everyone enable real time?
Cool.
Settings.
Select your ground plane. like on the top level, go up to the very top level, U to dive up or just get to the top level. And I want you to rotate your ground plane down a little bit. And now press play. And you'll see that your ball bounces downward. You also notice that this ground plane has these arrows going out in all directions. It's an infinite plane, even though it looks like it's not. It's actually stretching out to infinity, and you'll see that because your ball keeps going in the same exact trajectory. So to rotate, you need to go back up.
That's not keys, I should also do.
There you go. Select your ground plane and then rotate. You can use the handles to rotate. Don't go inside. Stay on the outside. You'll get used to the inside-outside stuff. And then select. So go. Yeah. You don't click. You just select. So it's just transfer ready. Select.
Oh,
Let's do this. Put your mouse here. Press enter. And now you've got your handles. So
Yeah.
now I want you to rotate that. There you go. Doesn't have to be perfect. Any rotation will do.
okay.
And now let's play to see what happens.
Oh.
Good. Yeah, is it doing it? Okay, great. T
Right?
translate. E and R need to be swapped.
Oh.
You're close.
Oh.
Yeah. So go back into the green auto dop. And I want you to take your rubber ducky, go to the physical tab, and let's increase your friction. And check out what happens. Let's take down the bounce to 0.5 again, that's the default. Let's take the friction all the way to like a large number. Let's see what happens there. Yeah, it's not hugely noticeable, but because the gravity just completely is taking over here. But friction should slow it down a little bit if you take that to a high number.
There's really no difference anything higher than 10 at this point.
Yeah.
It doesn't allow me to change the number to anything higher.
Maybe 40%.
Are you pressing play? It should be press stop.
Okay.
Stop your sim, and then I think you'd probably have to you've got gravity down here. You have gravity down here. Gravity is a negative 9.8 and some change. Take that down to like -1. Let's change gravity. Why not?
You got that 10,000 feet out of like that.
And there's no difference.
So we're about to start something new anyway. This is just like an introduction to RBD. But the structure is what I kind of want to point out here. So we have our hero object coming down to a rigid body solver. And there's tons of solvers in dynamics and DOPS. We call them DOPS. Everything has the ops sound. So in DOPS, we have a whole bunch of solvers. This guy needs a rigid body solver because that's the type of dynamics that our RBD object up there. Our ground, though, is a static solver. A static solver doesn't really do anything. You'll notice that both of these icons have brains on them. The solver is the brains of dynamics, and every next frame, it solves for the next frame. So the next frame is entirely dependent on the previous frame. And the floor doesn't really do anything, right? All it needs to do is just lay there and be a collision. So that, whenever you have collisions that are just static, they don't move, but they need to be felt, those are static solvers, those are static objects. That's your ground plane. That's the stream going up here. All of these get merged. Your solvers get merged. Your objects go into solvers. The solvers get merged, and then your forces are underneath that. So right now we only have one force, and it's the gravitation force. And the AutoDOP, the shelf connected this whole network for us. We're gonna make our own from scratch now, but just so you know, when you're on your own and learning Houdini, please use the shelf to get started. It's such a great way to learn. And this whole rigid body tab is there for you to play with. And all we did was we pressed, we created a ground plane collision, and we created this rubber ducky RBD hero object. Clicking either of those will create your AutoDOP node, and it will hook everything up automatically for you. The shelf tool hooks everything up automatically for you. But now in our next lesson, we're going to do it from scratch. And what we're going to do is learn how to use something called pin constraints. And we're going to have a chain. We're going to create like a chain of beads, and they're all going to be connected to each other. So let's get started. Any questions before we move on? Okay, great. So I'm going to get rid of everything here.
Do you think we should go over map boxes?
To get organized. Yeah, I just deleted everything in mine,
Okay.
but as we go, we'll introduce that. Okay, let's make a sphere. So I'm going to press Command and hit sphere on the shelf. And I'm going to just click on the name sphere object 1 and type the word chain. This is a geometry object. I'm going to select it and go inside. Okay.
Sorry, I missed it. Where do you type chain?
You just select the word and you just type your name.
Oh, okay.
Okay, so if you go inside and you've got your sphere, okay. I'm going to take a look at my parameters. So if I select sphere, if I select my sphere, I see that the radius, the shelf makes these automatically for you. What I want you to do is just press 1, 1, and 1. So our sphere is a size 1, 1, 1 all the way across. 1, 1, 1 all the way across. Okay, next we're gonna create some more nodes here, and I'm gonna press tab, tab line. Now you'll notice, Courtney and Connor, since you weren't here last week, when you click on these right display flags here, either by clicking on this guy or by clicking on this one. Actually, it's kind of tricky with my Wacom to get that. And then pressing G or space G, you'll see the object. You won't see any object unless your display flag is on that object.
I don't see line. Where's the tab? Is the box line?
And type line, L-I-N, just type it. So tab, type, L, yeah, there you go. And click on line, good. Just lay it down and then, yeah, hit that, there you go. And that's how you get your objects. You use the tab menu, you type it, you lay down the node, and then you put your display flag on that node. Okay. So now we have our sphere and we have a line. I want to copy a sphere at every point on this line, okay? But if we look at if we bring up P for the line, which is our parameters for the line, right? We only have 2 points. The copy to points that we're about to use works on the points. So we need more points. So instead of 2 points here, instead of 2 points, I'm going to put 10 points. And we see our points by this point display right here. This guy right here, this is our point display. You can turn that on and off to see where your points are. Especially on a line, since it's just a line, you don't really see the topology. Okay. So we've got that, and then we have a length. Let's increase our length to 30. The last thing we're going to do is right here, instead of 0, 1, 0, which makes our line stick straight up, we want our line to be going in Z, so it's 0, 0, 1 going this way. 0, 0, 1 in direction. So everyone should have something looking like this. We talked a lot about attributes last week. Basically, attributes live on geometry components. Right now we're going to create a color attribute, tab color, and these are going to live on the points of the line. So I'm just going to connect these two nodes. I'm going to click once on the output of the line, once on the input of the color, select my color, and I'm going to say random. I can turn off my point display. I don't really need that anymore. But you should see a colored line. The line is being colored by the points. Each point on the line has a random color. Make sure that the color type is random. Color type. So I want you to right click on that right there, on the word length. The word, yeah, Lily channels. Yeah, right click. I think you're middle click. Oh, wait. Oh, there you go. Lily channel. Okay. One more time. In length, the word length. There you go. So now, this one's 30. That one's 10. Okay, perfect. Now plug that into your color.
Yeah, it's already kind of changed back up to dark, so it's
Did I
easy.
select your color? Make sure it's random, make sure you got it. Yeah, you're good. Okay.
It got funky.
Yeah.
It'd be easier if we change the background to black.
Sure, yeah. So with my mouse here, I'm going to press D for display, get my background, hit dark.
Light to dark. There you go. Then you're gonna zoom in on whatever you expect to just do space G. You'll just bring that into focus.
Now press tab, copy to points. Copy to points is what we want. Copy to points. Copy to points. I'm going to, you see these two red triangles, it has two requirements. We want to put the object we want to copy on the left and the points to copy on to the right, and then put your display flag, and now you should have all of your spheres copied onto each and every point, and you can play with,
First input
if
is
you want, you
primitives.
can play with the point number.
Which one did you print? Yep. That's your
To see what
primitive.
happens.
So just, first input is your primitive. Yep. And just make it live.
I love teaching with these great tablets.
And if you turn off
It's like I
your
can
points
just
here, it tells
override
you the colors you can.
everybody's mouse so easily. That's great. Okay, so now you see how to see the difference. You don't have to type.
So just on that word, and, yep, and if you turn off points,
See it a little better.
there you go.
It's fun, right? And you know, you can swap out the sphere for any object and it'll just copy it onto those points. Okay. Now what we're going to do is create pin constraints between these spheres so that they're all connected into like a bead like object. Right now, we're going to we're going to pack this geometry. Okay. So right now we've got 2,800 polygons. I want you to press tab, and we're going to use a SOP called assemble. Tab assemble. And we're going to say create packed geometry. And now we only have 10 polygons. So it saves it. It packs up our geo and sends it off into memory. And right now we're just referencing. It creates, in a sense, a reference of the geometry. So we're not dealing with the geometry itself. We're dealing with a reference to the geometry, and that makes your rigid body objects, your rigid body simulations a lot faster. And you might not notice it now because we don't really have that many beads on here, but when you're dealing with when you get more complex, this is going to speed up your simulations a lot. So we're now, once you pack it, we're dealing with the reference. Okay, now at this point, these are going to be the objects we want to simulate. After that, at this point, we're going to branch off and create the constraints. We're going to create the wiring that's going to glue all of these guys together. So I want you guys to put down a null. Tab, null. I'm going to say objects underscore out. Objects out. We can also call it beads out too. Maybe objects is too vague. Beads out. We make nulls because we're going to fetch this guy in another network. So we always make nulls when we know that we're going to import the null into a different network. Okay, under the null, I want you to say tab delete. We want to delete our objects but keep the points. So here's how we're going to do that. In Houdini, if you just put a asterisk, this is another little shortcut. An asterisk in Houdini, this guy, it means everything. It's like a wild card. It means delete everything. That's what an asterisk means. But if we say keep points, keep the points, then we get our points back. We want to keep the points. We want to delete the balls. That's what we're trying to get to right now. Yeah. Yeah. Oops, I disconnected them. There we go. right now it's saying not everything by having both. It's basically like, when you have both of them there, nothing happens because they're like canceling each other out. So basically, that's like the default. If you take away the exclamation point, just keep that asterisk, it means delete everything. And then you keep the points, you click on that little checkbox, keep the points, because we just want those points to create our constraint network. Okay. We're going to take our balls and give it gravity and simulate them, but we need an anchor. We need something that's gonna stick so that our beads are gonna fall and there's something that's holding them in the air that's not gonna move. We need one more point, and we make a point with an add SOP. An add, tab, add, tab, add. And all we do is we enable we're gonna enable 0.0. We're gonna say 0, 0, -2. And I'm going to zoom in so you can see. 0, 0, -2. If I go up to the delete, it's not there. If I click on my add, it's there again. Okay, let's get rid of this origin red, this red like gnomon in the middle of our display screen. I'm going to say D, go to guides, and I'm going to take away my origin gnomon right there. I'll do that again. D, origin gnomon right there. The other thing I want to do is go to my geometry tab, go to the display particles. Let's see here, yeah. Particles and points are considered to be the same thing. I just want to increase my point size so that I can see my points better. And that's under geometry. Geometry, particles, point size, we just increase that right there. And then again your guides, origin geometry, you click that off. So just so you can see, this is before we added the point, and now I've got my extra point right there. Does everyone have that? Okay. I want you to put another node. It's called connect adjacent pieces. Connect adjacent pieces. Select on your length attribute. We're going to say adjacent points. Increase your search radius, and then all of a sudden you're going to see that a line forms, and these are going to be your constraints. So if you just increase your search radius, have your adjacent points,
You can also do that.
Sometimes Okay, let's check out this warning. Okay, no worries. Figure out that. We'll worry about that later. Okay. We need to create an attribute because this attribute is what our dynamics is going to be looking for. So we want to make it first. I want you to put down a node called attribute create. Tab, create, attribute create. It's right here. Attribute create. And we need to create an attribute name. The name of this guy needs to be spelled right. Constraint underscore name. Constraints always live on primitives. In Houdini, primitive is another way of saying a face. Or it can be, well, in this case, it's like we have no faces, we just have lines. But in Houdini, it's the same thing. It's like the line, the face. It's not going to be the point. Those are points. So primitives are lines and faces. It's the type. The type is going to be a string. And I'm just going to call this pin. This one you can name anything you want. The name has to be exactly that, constraint name. But the word pin, you can name it whatever you want as long as you remember what it is. So constraint name, primitive, string, pin. And then we're going to put a null and then go into docs. So this is the end of our constraint creation. It exists on the line. Let's put a null, tab null. I'm going to say constraints out, all uppercase, sorry. All uppercase. All of our nulls are always uppercase so that they go to the top of the list when we fetch them. Okay, everyone have a null? Let's get into our dops. Tab. Dot network. tab.net. This time it's inside. We're just making a .net inside. Okay. Now go inside of the stop net that you just made. Okay.
If you accidentally connect it to your constraints, how do you,
Why?
why?
Wait, what?
I accidentally connected the line.
Hold down line and drag.
Oh yeah, hold down Y and then it turns into a scissors.
Why? Break.
Yeah. But you have to know how to use it. You just hold it down and then slash. So go inside of your dynamics, delete that output node. You can leave it there if you want, but you don't need it. We need a ground plane. Tab, ground plane. That's weird. I'm not seeing mine. Huh. Oh, wait. Go to frame 1. You won't see anything unless you're on frame 1. Okay. We have a ground plane. Under our ground plane, we need a static solver. A static solver. Tab, static solver. Tab. So let's put this to the side. Now we have our static ground plane, but now we want our RBD packed object. Tab RBD, RBD packed object. This is where we're going to get our beads. So I'm going to look at my SOP path, go all the way to the right and click on that chooser. And you see that because we named our nulls all uppercase, they shoot to the top of the list. So we want beads out. And now we should see that our beads have been imported. Okay, next. I want a bullet solver, just very similar to the previous solver that we tab bullet. Okay.
Did you explain the RBD pack solver one more?
The RBD packed object, you mean?
Oh, the pack object.
Okay, 1 second. RBD packed object. This is going to be your source. And basically we just fetch the geometry that we just made into this object. Now if it was not packed, you would use a different object. So you would use the rubber ducky. So if you look, these have a bowling ball and the pins there. So tab RBD, if you look here, you've got an RBD object, which is the rubber ducky, and you've got an RBD packed, which is the bowling pins. So because we packed our objects, we use a different node called the RBD packed object. And remember, our packed objects are references. to the actual object. So it saves memory. You don't have to worry too much about that now, but just know that this is just when you have many little objects that you're trying to simulate, we use packed geo for a faster simulation. It's references. We use a bullet solver. And then you merge the two solvers together. Tab, merge. Why can't I? Merge your two solvers together. Now we see that they're interpenetrating. I'm going to select my ground plane, and with my middle mouse just kind of bring down that ground plane so that my beads have kind of some space to fall. One more note, and I'm going to go around and make sure everyone's good. I'm adding gravity. They're a little boring. I'm adding a lot of bounce to them for now so that they're not so boring. But yeah, so you should have some bouncing balls now. Actually have to retrieve your beads. There you go. One. And then we need to
still at the beginning and then just bring the game.
It's cooking with gravity. One hit, then it goes up. As I hit, gravity affects the and then they come out. So you can have
There you go. Are you good over here? Just remember to put your slip on gravity if you want to see
just that
something.
one ball right there, that's affecting everything.
Okay, let's add our constraints. I'm gonna take my bounce back to default. And what I'm going to do now is I want a constraint network. Going to press tab, constraint, tab, constraint network. Something was weird happening with my wake up. I'm still trying to get used to this. So tab. That's what I missed too. Constraint network. I'm going to put my gravity in the left and just one more node, tab, hard, constraint relationship, hard constraint relationship. I'm putting that into the second. This hard constraint relationship, I'm going to type pin just like we made our attribute called pin. I'm going to spell it in the exact same way. So I've got this guy here. I'm going to call it pin. I'm going to select my constraint network. And I'm going to retrieve my constraints here. And now we should have okay, so here's something interesting. In your SOPs, if you go out of your DOPS, so remember how do we get up and out of our DOPS? You press U, up, to go up, press U. Connect adjacent pieces. If you are in this connect adjacent pieces and you see that the search radius, I had mine at a kind of a high number, like 3 or 4, and I put it back to 2. What happens is like it doubles up on constraints when that number, when the search radius is higher than it needs to be, it starts to build out more constraints. So look at the difference. I put that at 2 and I'm pressing play. Okay, that's my chain. I'm putting this at 5. Look at that difference. Do you see that? So it actually affects the strength of my, the look and the feel and everything about my constraints. So just put it at, and you can see it, like when you go here, it's kind of like just at the value where it becomes a whole line is right where you need it. As soon as you go overboard, you can see it even more. It's starting to build more and more and more connections between those points. So you just want, right when it becomes a line, let's take a look there. Otherwise, you're kind of doubling up on the constraints. There we go. So it's like loose. They're connected, but they're loose. You know what I mean? Like we don't want it to be so stiff. So I'm going to go back in, and this is what I got. Adjacent pieces above. I want you to take a look at this adjacent pieces from points. Oh wait, first put your display 5 on there. Let's take a look. See how there's nothing there? Okay. So I want you to look at your adjacent points, not pieces. That's right. Search radius motion from that a little bit. See how it just becomes a line? Now don't do too much because then you're going to get stiffness just when it becomes something. There. Okay, now go the other way. So we need it to be a line. That's cool that you can use your little thing. Okay, go the other way. There you go. Keep going, keep going, keep going. There. You're good. That should work. So now go to, now display 5 on your .NET. Let's play. Okay, so if we didn't create that extra point to add, it would be kind of a loose set of beads. They would be connected, but they would be kind of loose. This creates an anchor for us, so we're holding it in the air. How are we doing here? No worries. So let's go inside your .NET. You can either double click or press I, either one. Or turn it down. Also enter, there's like a billion ways to get inside. Okay, so here, okay, so there's nothing here, so I want you to press that button. Constraints out. There you go. Yeah. Want to press play? Okay, almost there. If your hard constraints, I want you to type the word pin. Uppercase P, if that's what you did. Okay, cool. Press enter. Okay, and then go to frame 1. Right. Okay. So let's that's what a teacher is for, right? To know that it's right, even though it's not working. Right? It's exactly the same. But it's not there. See how weird that is? Nodes break. For no reason, just break. Whenever that happens, just make it again. Everybody good over here? Okay guys, let's take a short break, come back, and then now we're gonna destroy a wall after break.
Are we stopping Camtasia?
Ooh, yeah.